Good morning to all of you. I welcomes to all in our lecture series on quantum mechanics. We are discussing the topic particle in a finite square wave potential, that is the so-called bound state. So actually this is your part 2 video of this topic. In the part 1 we have been discussed up to this much. May you remember that up to this much, that by considering equation 23rd, 4th, 25th, 30, 31, 32, we got this and this. From here we are going to be discuss in this lecture or video, and what we discussed in our last class. With a quick revision I am going to be discuss, you just watch it. Actually the situation here, or the problem you can say, is here that a particle having the mass m is trapped inside a well. That means this side the potential is 0, this side is potential is 0 in region 1 and region 3, and the region 2 having the potential is negative, and the energy of the particle, the total energy of the particle, this dotted line is represented also negative, but the magnitude of this total energy is greater than that of the potential of this region 2. So hence we can get the oscillatory behavior of this particle in this region 2, but exponentially decreasing behavior in region 3 and region 1. So how it is, why it is, I given a separate video about bound state and unbound state. I suggest that you go through that video. So here this is the representation of the potential. Region 1 0, region 2 minus v 0, and region 3 is 0, and we written the so-called time independent Schrodinger equation for region 1 is your equation number 2, for region 2 is equation number 3, and region 4 is belongs to time independent Schrodinger equation of region 3, that is equation number 4. And now the general solutions will be in the form of 5, 6, 7, but however we are going to be consider the boundary condition. If we are going to consider the boundary condition is this one, then this is going to be infinite when x tends to minus infinity and x tends to plus infinity. So this wave functions is not going to be considered. Okay, and other way of the representations of this boundary condition, how it will be, you can found, I given you a separate video, that some other books they have been represented these things. So the physical meaning is this same. That means this and this is not going to be acceptable, because this is giving the value of infinite and this giving the value of infinite whenever we are moving to the minus infinity plus infinity. So these two things is not going to be acceptable if we are going to consider for the region 1 and region 3. But other way, some other books they have been represented. How it is, I given a separate video. For that you can go through that. So in your exam you can write in this way or in that way, whatever I represented in a video. I will give that video link description of this video. Okay. So finally we got the solutions of the three regions is this one, considering the boundary conditions, these, and after simplifications we can found here the major equation is this one, this 19. This is k equal to beta tan beta a. 19 is, this is the major equation, because this equation have the applications in our preceding sections. Okay, so another k value we got is equal to minus beta cot beta a. Okay, so and this is belongs to your 25 is belongs to your first group solution. Some books they have been written that first class solution. Okay, and likewise 32 equation number 32 is considered as second group solution, or some books are written as second class solution. You can write anyone in your exam, but in note I suggest that you can write in this way, second group or second class solution, like this. So up to this much we have been discussed step by step. I suggest to all of you that you go that video and watch this video. I suggest watch this video after watching that video, that part 1 of this topic. Okay, so now here we found finally the results. What we found by considering equations 23, 24, 25, 30, 31, 32. A equal to G, D equal to 0. That implies A equal to C into e to the power K into cos beta A. Okay, 23, 24, 25. Considering these three, we found this one. A equal to G, D equal to 0, and hence A equal to this one. Okay, likewise considering 30, 31, 32, and this one. So with systematically I have been written this and this. Now if we are going to consider this one, then what will be the value of the psi 1, means wave function in the region 1. Okay, so here again before that I am going to be share with you one thing, that this A equal to G, D equal to 0, A equal to this much we found by considering this one. See here, by considering 19 equation, you can if you can go through the part 1 video, and you can found that by considering equation 19 we found this one, this value A equal to G, like this. Okay, by considering 26 we found this one, A equal to minus G, C equal to 0, this one. Here also I written, no problem. So psi 1x, how much it will be if we are going to consider these things. So psi 1 is nothing but your A e to the power kx. So instead of A we can write C e to the power ka cos beta a. So psi 1x will be C e to the power ka into cos beta a into e to the power kx. Psi 2 is C beta x plus D sin beta x cos sin. So here D equal to 0. Here D equal to 0. So we can found psi 2 will be equal to cos beta a. This is the wave function belongs to your second region. Wave function belongs to third region will be how much? Here G to the power minus kx. We found A equal to G, right? A equal to G here we found. Here A equal to G. So I can write instead of G this much, C e to the power ka cos beta a into e to the power minus kx. Similarly, by considering A equal to minus G, C equal to 0, G equal to D into e to the power ka into sin beta a, we can found psi 1x equal to minus D e to the power ka sin beta a into e to the power kx. We have to just put this value over here, but here A equal to minus G, so it will be minus. So it will be minus e minus d e to the power k sin beta a into e to the power kx. Okay, psi 2x, here c equal to 0, so psi 2x will be d sin beta x. See, c equal to 0 means psi 2x will be d sin beta x. And psi 3x is nothing but is your g e to the power minus kx. So instead of g we have to put this value. This value means it will be d e to the power k into sin beta into e to the power minus kx. Okay, the above solutions, the above, watch carefully. Okay, many new things you can found. Carefully you have to watch. You can see that the above solutions, these are the above solutions, are found by using the equation number 19. I told that is the equation number 19 is this one. By considering this we got this value, because by considering this we got this one, a equal to g, d equal to 0, a equal to this much. So hence psi 1, psi 2, psi 3 we found by considering k equal to beta tan beta a. Okay, similarly here I separated discussed this one and this one. So I drawn a line here. Okay, now here the above solution, similarly we can write here the above solution, these solutions are found by using the equation number 26, that is k equal to, this is your equation number 26, right? By using 26, actually by using 26, this one we found this one. So by using this one we found this one. So hence by using equation number 26, finally we found the wave functions in region 1, 2, 3 are this. For this by using this one, equation number 19, we found the wave functions psi 1, psi 2, psi 3 are this. Okay, so here you can see psi 1 and psi 2 are exponential decreasing function, because see these are the positive value. Here in case of psi 1 means region 1, we have to take x as negative value. So psi 1, if we are going to increase x value, that means negative x value, this value is going to be decreased. Okay, and psi 3 also we have to take positive x value here in region 3. In region 3 means this one, 1, 2, 3. So in region 3 means this one. So here this is reducing, this is decreasing. Okay, this is minus a, plus a, and the length is 2a. Okay, so decreasing function with x means with increase of x, but here you have to consider that in region 1 x is increasing this side, means the negative value is increasing, along in region 3 the positive value is increasing, means modulus of we can say modulus in region 1 and 3, the mod x is increasing. This side if we are going to increase, decreases, this side the wave function also decreases. So like this it has been written here, psi 1 and psi 3 are exponential decreasing function with x. Here also same thing is written, psi 1 and psi 3 are exponential decreasing function with x. Why I am discussing these things? Because these similar things we got by considering this equation and this equation also. Okay, but if we are going to consider psi 2, that is belongs to wave function in region 2, the wave function is region 2, here you can found this is cos beta a, psi 2x, oh sorry, here I written mistakenly, wait, see here if d equal to 0 it will be c cos beta x, here I just simply mistakes, c cos beta x, this will be c cos beta x, you just write c cos beta x. Okay, c cos beta x. Now so here we can found that in region 2 both are oscillatory, one is c cos beta x and another is psi 2 x is nothing but d sin beta x, right? So both are oscillatory, but this is an even function, cos function means even function, this is an odd function. So here psi 2 sometimes a even function and sometimes is a odd function. That means from this itself, from this derivation itself, it is indicates that whatever the wave function we are going to get in the region 1, that will be the oscillatory. So this is our x is equal to 0. If it will be cos x, then it will be like this. It will be like this. Means at x is equal to 0, it will be maximum. It will like this, or at x is equal to minus a, it will be minimum. Okay, or you can say that it will be like this. It will be like this, means at x is equal to 0, this is a cos function, but if it will be sine, then at x is equal to 0, it will be minimum. It will like this. Okay, so either this or this. So sometimes some for some condition it will be even, and some condition it has to be follow and it will be odd or sine. So what will be the condition, that we are going to discuss in detail in our preceding sections here. So what I discussed, that I written here, you just you can write in your note here. See, psi 1 and psi 3 are exponential decreasing function with x, but psi 2 minus x is equal to psi 2x, because it is even function, cos function, which is represent the solution, that is even parity. Even parity means if any wave function is follow this condition or property, then that solution or the wave function is nothing but called as the even parity. Okay, that we know at the time of when we discussed the operators. So here but for this case psi 2 minus x is equal to minus psi 2x, because here psi 2 is belongs to odd function. So psi 2 minus x is equal to minus 2x, as it will be followed this one, which represents, so we can write, which represent the solution is odd parity. Okay, so from here itself we can perceive, or we can understand one thing, that the region 2 will be oscillatory, but sometimes it will be follow the even parity, sometimes it will follow the odd parity. This is odd, this is even parity. So when it will be even, when it will be odd, that we are going to be discuss in our preceding section. So here one thing I written, so here you can see that here the here it can be noted that both equation number 19, that is k equal to beta tan beta a, and equation number 26, that is k equal to minus beta cot beta a, are called as this. This word is new for you, that is, see, Transcendental. You can pronounce as transcendental equation. So these two are called as the transcendental equation. This is equation of the so-called equation number 19 and 26. This one, this and this are the so-called transcendental equation. Okay, now we have to move to the next page. You can mark that this is the page number 8, and we are going to be move for the next page. Actually in this note the page is completed, so I used another note. This is another note, that is your equation, that is page number 9. Page number 9, the heading is energy levels and corresponding energy and Eigen values. Now we are going to be discuss, or we are going to find out the what will be the energy levels that in the region 2. What we discussed, that in region 2 maybe even functions, even wave functions will be possible sometimes, and odd will be possible, but in different states what will be the value of, or what will be the solutions or eigen functions in the region 2, and the corresponding, this is, suppose this is the state having eigen function is this one, what will be its eigen value that we are going to be start to discuss. So previously we know that k square equal to 2m e by h cross square. From the beginning itself this things we have been written, that let k equal to 2m e by h cross square. Okay, you can see over here that here k square equal to 2m e by h cross square, and beta square is equal to 2m by h cross square v0 minus e. At the time of region 2, you can check for the region 2, you can found here beta square we have been taken as 2m by h cross square v0 minus e. Okay, so now k square plus beta square will be equal to 2m e by h cross square plus 2m by h cross square v0 minus e. So it will be k square plus beta square will be here plus and minus is going to be cancelled out, 2m v0 by h cross square. So here k square plus beta square into a square, this side also I multiplied a square, so 2m a square by h cross square v0, let it is equation number 33. Up to 32 we considered up to 32 here, and let this is equation number 33. I suggest to all of you that this is your page number 9, and page number 8 means this one is your page number 8, up to this much transcendental equation. So you pause the video at the time of whenever I am discussing line by line, you pause the video and you can write the note. So now, in order to obtain the graphical solution, consider k equal to mu and beta a equal to lambda. Okay, actually I forgot to write one sentence here in order to obtain the graphical solution. That means here I forgot to write one sentence here. You can write here, I have been written. Now you just, after writing this one, you just follow me. I am going to be zoom this one for you. You can easily can be read here. Here it can be noted that both equation number 19, that is k beta tan beta a, and equation number 26, this one are called transcendental equation. After this line you just write this two line. So for better visibility I am going to be zoom for you. You can write, see, I am going to be show you over here what I written. You can see that this two line you have to write after this transcendental equation. Then you have to write, to obtain the energy levels LEVEL. This is LEVEL. Okay, to obtain the energy levels and corresponding eigen values, the transcendental equations is to be solved by graphically. This is written as graphically, GRAPHICALLY, graphically. Graphically we have to solve these two transcendental equation. Here this is one transcendental equation, this is another transcendental equation. By considering these two transcendental equation, we have to solve these two equations graphically to find out the energy levels and corresponding energy eigenvalues. So you write this one, okay. Pause the video and you have to write, to obtain the energy levels and corresponding eigenvalues, the transcendental equations is to be solved by graphically, okay. Now come to this page here. We have to start from here, okay. Now in order to obtain the graphical solution, consider Ka equal to mu and beta A equal to lambda, and going to be substitute over here. However, here mu and lambda will be positive because K, beta, A all are positive. So mu and lambda will be positive. Now the transcendental equations will be by substituting Ka as mu. This is, see, the transcendental equations. The transcendental equations, that means your transcendental equation means this one, equation number your 19 and equation number 26. This is equation number 19 is equal to K equal to beta tan beta A. Here the transcendental equations, equation 19 is your how much? That is K is equal to beta tan beta A, and equation number 26 is nothing but is your K equal to minus beta cot beta A. So here by considering Ka equal to mu, beta A equal to lambda, that means this 19 is going to be modified as like this, multiplied with A, so it will be Ka will be beta A into tan beta A, and 26 is going to be, it will be Ka is equal to minus beta A cot beta A, okay. So here I just multiplied A, this will be this one and this will be this one. And another thing I am going to share you, some books they have been written that this is the so called transcendental equation, this is transcendental equation. Don't be confused, because here both are same. Here just we have been multiplied only A. So I told that this one is transcendental equation in this discussion, so should not be confused. So here instead of Ka we have been substituted as mu, and instead of beta A we are going to be substituted as lambda. So here this equation will be written as mu equal to mu equal to, this is lambda, because beta A considered as lambda, no, so it will be lambda tan lambda, and this will be considered as mu equal to minus lambda tan lambda. Beta A is nothing but lambda, here beta A is nothing but lambda, so instead of beta A lambda, tan beta A means lambda. So this also can be written as lambda, sorry, this is cot means this is cot lambda, okay. So this minus lambda cot lambda can be written as lambda tan lambda plus pi by 2, okay. Tan lambda plus pi by 2 is nothing but minus cot lambda. So hence this minus lambda cot lambda can be written as lambda tan lambda plus pi by 2. So those things I have been written here. Now the transcendental equations will be here mu is equal to lambda tan lambda for even solution. Okay, here I indicated even solution, that means this is belongs to your equation number 19. See, this is your even parity. How we got the even parity? By considering this equation number 19. Okay, so here I in bracket I written for even solutions, or this mu equal to lambda tan lambda, or you can write here in bracket also from equation number 19. Also you have to write over here, that you can easily understand. And this is also you can write from equation number 26. Okay, because the 26 equation is belongs to your k equal to minus beta cot beta a. So this is your 26. So by considering this one, we got lambda tan lambda plus pi by 2 is this one. Okay, so by considering k equal to mu and beta a equal to lambda, now the transcendental equations will be mu equal to lambda, this is lambda, okay, lambda tan lambda for even solutions. Just in bracket we written from equation number 19. It has been derived. That means the transcendental equation 19. Okay, so let it is equation number 34, and from transcendental equation, that is from equation number 26, or belongs to for odd solutions, we found mu equal to minus lambda cot lambda is equal to can be written as lambda into tan lambda plus pi by 2, because tan pi by 2 plus lambda is nothing but minus cot lambda. So it is equation number 35 we have been considered. Now we are going to be put the values of k and beta a in equation number 33. So here we can found that it is k square a square beta plus beta square a square is equal to this much. So here k a is nothing but mu, so k square a square will be nothing but mu square, beta square a square will be nothing but lambda square. So k square a square, now the equation number 33 will be k square a square plus beta square a square will be equal to, instead of k square a square it will be written as lambda square beta square a square mu square will be equal to 2m a square v0 y h cross square is equal to r square. Here r square is considered as this one, this much value has been considered as r square. Okay, or r equal to root over of this one. Let it is equation number 36. Now from 36 you can see that lambda square plus mu square is equal to r square. That means it is the equation x square plus y square is equal to r square. That means this equation is looks like this one, lambda square plus mu square is equal to r square, look like a circle equation, right? The equation number 36 represents a circle of radius r is equal to 2m r square v0 by h cross square. Okay, the even solutions can be obtained by simultaneously solving equations 34, 36. See here, mu is equal to lambda tan lambda we found from equation number 9, that is for even solutions. You got it? So this is your k equal to beta tan beta is the transcendental equation is for the even parity. This is for odd parity, right? So from this, by considering this one, we found this one by considering this one minus beta cot beta a, we found this one, right? Now by considering both, we found this circle equation. So now even solution can be obtained by simultaneously solving equations 34 and 36. See, combined equation is 36, only even solution equation is 34. So if I am going to be consider the 34 and 36 equation combinedly, and if I am trying to solve the 34 and 36 simultaneously, what we can found? We can found even solutions. Okay, that means the wave functions belongs to even parity. Okay, that is graphically. That means even solutions can be obtained by simultaneously solving equations 34 and 36 graphically. Likewise, the odd solutions or the odd parity wave functions can be obtained by simultaneously solving 35 and 36, because this 35 has been obtained by considering this one, by considering this transcendental equation, so which is belongs to odd parity. Okay, so as this 35 is belongs to odd solution, so considering combiningly 35 and 36, we can get the odd solutions. Okay, but both are going to be solved by graphically, because here mu equal to alpha tan alpha for even solution, here mu equal to alpha cot lambda, mu equal to lambda tan lambda, here mu equal to minus lambda cot lambda. So here both mu is the function of lambda but belongs to even, here also function of lambda belongs to odd. So the odd and the even and odd solution is going to be separately evaluated if we are going to consider this 34 and 36 simultaneously graphically, and odd solutions can be obtained by considering simultaneously this equation 35 and 36 and solved graphically. Okay, so that we are going to do in our next page. That is your page number 10. Here we completed the page number 19 contents. Up to this much writing here we completed here, and we moved to the page number 10 by plotting the graphs and finding the solutions. This is your graph. We are going to discuss step by step. Wait, here what I written here, either even or solution represents the energy levels or energy states of the particle. That means here we discussed that by considering these 34 and 36 simultaneously, we can get the even functions, and considering this and this 35 and 36, we can get the odd function. So obviously both the odd solutions and even solutions will be represent the energy levels or energy states of the particle. That belongs to second region. Why I am going to say that second region? Because first region and third region. In the first region, see, this is our first region, and third region, this is the second region. This is the bound state region, this is the bound region. Okay, particle will be here, but some probability we can found here and here, but it is a decreasing manner. But here is bounded, means we can get the bound states energy states in this region. Like this discrete energy states we are going to be found, that we are going to be discuss in this page 10. You just wait. Here I am going to share with you one philosophy. You just think that suppose you are inside inside your home, okay, and your parents restricted you to move outside, to move to play, to move to roaming here and there. Your parents is fully restricted. So what will be your mental condition? Mental condition is going to be anxietiness. Your anxietiness is going to be increased, means your discreteness, your disturbance mind is going to be increased. That means here if a particle is going to be bound like that, its energy states is going to be different energy states is going to be found. That is called the so-called discrete energy states or bound states we are going to be found, that we are going to be mathematically we are going to be discuss over here, you see. Now first what I written, we have to just read it. In the above means in our previous discussion we found both lambda and mu. Here both two times I written, both lambda and mu are positive values. So the energy levels or the solutions belongs to first group or first class. First group or first class means it is indicating the even parity, okay, can be found from the intersections in the first quadrant of the curve lambda tan lambda. I told that mu, this is the mu equal to lambda tan lambda is belongs to your even solution, okay. So can be found from the intersection in the first quadrant. Why we are considering the first quadrant? Because this lambda and mu both are positive, so only for that we are considering the first quadrant of the curve lambda tan lambda versus lambda, okay, with circles of known radius. That whatever we discussed, that if we are going to consider this and this at a time, this is a circle equation, this is one tan function, mu equal to tan lambda, but here lambda one value is multiplied with tan function. So whenever we are going to consider the intersection of the circles with this curve, then we can found the first group solutions or the even solutions or the solutions which have the even parity, right? Now similarly the energy levels or solutions belongs to the second group or second solution can be found from the intersections in the first quadrant. Because why we are considering the first quadrant? Because all are the positive values, lambda, mu, all are the positive values of the curve lambda tan lambda plus pi by 2 versus lambda with circles of known radii, that is figure 3. So in figure 3 these things has been represented, in figure 3 also these things has been represented. This one you can see this is the figure. Carefully you have to draw this figure carefully. I am going to be explain what you have to draw exactly. See, this is the dotted line. First along x-axis we have been taken as lambda, okay, along y-axis we have been taken as mu. Here mu have the two values, one is lambda tan lambda for even function, right, another is lambda tan lambda plus pi by 2 for the odd function or for the solution which belongs to odd parity, right. This dotted line mu belongs to dotted line is the even, dark line is for the odd. You can see that this is the pi by 2, pi, 3 pi by 2, 2 pi, okay, that means pi by 2, again pi by 2, pi by 2, with increase of pi by 2 we can found along x-axis. This is pi by 2 plus pi by 2 means pi, again plus pi by 2 means 3 pi by 2, like this. So here first you can see the dotted lines. Where is the dotted lines? This one is the one dotted line, like, right, this is belongs to lambda tan lambda, okay. The next one lambda plus pi by 2 means this one. This is the dark line. This is the dark line, means lambda tan lambda plus pi by 2. Okay, next dotted line is this one. Next dark line is this one. Okay, whatever the figure represents, that I am going to explain, and the physics behind this figure or the mathematics behind this figure I am going to be explain. Wait, see carefully, you have to draw this figure, because why I am telling to you. See, we know that in case of tan theta, only tan theta versus theta. So what will be the curve? This is pi by 2 and this is pi, this is 3 pi by 2. I am considering the x-axis only and first quadrant only. This is the first quadrant, this is your tan theta and theta. How it will the curve? Curve will be this one. Both are same, means 0 to pi by 2. What type of increment with the theta? Okay, from pi by 2 to pi, exactly same type of increment we can found, right? And from pi to 3 pi, similar. That means if I am going to cut this portion and put over here, exactly match. This is your tan theta curve. So tan theta plus pi by 2 means we can found here one portion, that means theta plus pi by 2 means portion here, and another portion will be we can found after 3 pi by 2, this one, like this, or the so called minus cot theta. Okay, so here what I am going to say to you, that in between this limit, all the curves are same, not full same. The increment with the theta is same in between this and this. Okay, but here in our case, the mu is not only the tan lambda. That means mu is not only the tan lambda function. We are taking along x-axis lambda, but another lambda is multiplied over here. You got my point? So here you just think that if I will move from 0 to pi by 2, this value, this curve is belongs to only tan theta. But if I am going to multiply one theta, so as theta will be increased, the tan theta value is also going to be increased. That means initially, suppose we are going to consider tan theta. This is the graph. If I am considering theta into tan theta, that means this is pi by 4. Suppose pi by 4. Initially pi by 4 value will be this much. But if I am going to consider theta tan theta, that means pi by 4 value is multiplied with the tan theta value. Initially value will be this much. If we are going to consider tan theta into tan theta, this value will be increased up to here. So the graph will be somewhat like this. Means all the value is going to be increased. Okay. Similarly, suppose we have to consider lambda tan lambda. This is the dotted line. Okay. At pi by 2, obviously it will be asymptotic behavior, means it tends to infinite. Obviously because sin theta by cos theta. But if we have to consider another value, that will pi, that is lambda tan lambda here, that means here lambda increases, lambda tan lambda value also is going to be increased. So here suppose here this value at this point, suppose pi by 4, this value will be this much. Here this value will be increased. That means the curve will be like this, what I discussed here. Okay, so here initially the first curve dotted line will be this one, lambda tan lambda for even one. The second dark line will be somewhat, initially it will be like this. Okay, the second one will be somewhat this curveness is going to be reduced. Okay, the third one again it will be straightness is increases. You identified. Okay, what I am going to explain, you just watch it. This is curve, here it is curve. this curveness is reduced, this curveness is reduced, this curveness is reduced, because at this point whatever the value, for next one it is increases somewhat. Okay, for next it is increases, for next it is increases, because we know that 0 to pi by 2, that means at pi by 4 whatever the magnitude of tan theta, that is pi by 4, 2 pi by 4, 3 pi by 4, also magnitude will be same, magnitude of the tan theta will be same, but here as lambda is multiplied, this magnitude is somewhat increased. Again this is 3 lambda by 4, 4 lambda, 5 lambda by 4, the magnitude should have to be same as tan theta, but as it is multiplied with lambda, again it will be enhanced. Okay, and with increase of lambda, this value is going to be increased again and again. It is not it is increasing because lambda is also increased. So hence the curvature of this curve is going to be like this, like this. So these are the curves you have to draw perfectly. This is belongs to the dotted line. Here I consider 2 dotted lines belongs to lambda, tan lambda, which will give the even function, and this dark line will be give you the odd functions. Right. One thing, another interesting thing you are going to be you can judge it here. See, the interesting thing is that you can see here this closeness of this curve with this pi by 2 will be here. Okay, at less value of mu. See, at you can see at this much value of mu, you can say that this curve is approximately touches with pi by 2, right? This much value of mu. Okay, but here it touches higher value of mu because the curve is like somewhat straight. Again for this curve, this closeness or is going to be touchness of this curve with this pi by 2 value will be higher, means around at this value of mu we can say that this dotted line is going to be touched, and again higher value of mu we can found that this is going to be closer or going to be tends to touch this one, means where it will be show the asymptotic behavior. That means here you can see for a particular mu value, here the closeness is larger, here it is close, here it is somewhat distance, it is somewhat distance, means if we are going to move from this side to this side, the distance, the closeness between this curve and this is reducing. That means how if we are going to be consider the other curves beyond the 2 pi, then this distance is going to be increased, means the straightness of this curve is going to be increased. Whatever we can found this from this equation, that is mu equal to lambda tan lambda or mu equal to for even lambda tan lambda plus pi by 2. So I suggest to all of you that you draw this figure by considering what I explained. That means your this one is will be somewhat curved and it is somewhat straight, it is again straight, it is again straights. The straightness is enhanced. Okay. Now what we can found when the circles of different radius is going to be drawn in this figure, where it will be cuts and what is the meaning of this cut, that we are going to be discussed in detail. Watch. That is the heading. You can put results and discussion, what we are going to be found from the graph. Here you can see for r is less than pi. Now we are going to consider the radius pi by 2, less than pi by 2. We are going to be consider a radius which is less than pi by 2. So r we know that 2m by h cross square a square v0 root over, here we considered that is r is this one. Okay, so or this much less than pi by 2, or you can write this h square can be moved this side, a square v square. First we have to take the square, so it will 2m by h cross square a square v square less than that of pi square by 4. So hence a square v0 will be less than that of pi square h square by 4m. For this case, whenever the radius is we are going to consider pi by 2. See here, this is the radius, whatever I am going to draw, this is the circle. I just drawn this one, this much. No need to draw a whole circle, but because we are searching the chords in the first quadrant, so this portion of the circle I have been drawn over here. The radius of this circle, this is the center, the radius of the circle is less than that of the pi by 2. So for radius less than that of the pi by 2, or a square v0 less than that of the pi square h cross square by 8m, if then there is only one bound state or intersection is found. See, only one intersection we found. One intersection on which curve? On dotted curve, that means even curve. So for r less than pi by 2 or this much less than pi square h cross square by 8m, only one state, one bound state or the intersection is found. That is for 0 to a square v0 less than that of the pi square h cross square by 8m, there is only one energy level will be possible. So one intersection means only one energy level is going to be possible, which is belongs to first group, because this circle is cuts with what? The even solution, that is mu equal to lambda tan lambda. This is dotted line. So hence that is belongs to first group or first class. This indicates that the corresponding wave function of the energy level. So what we found that in between this range 0 to pi square h cross square 8m, we can get the first group solution. The solution or the wave function will be belongs to first group, and the energy level will be the follow the even parity. If that wave function or the solution will be follow the first group, the first group is nothing but, or the first class solution is nothing but even type or even class. So hence the energy level will be follow the even parity. Okay, now we have to consider pi by 2 radius in between pi by 2 to pi, or pi square by 4, pi square by 4, in between pi square by 4, 2m. Here I written instead of r is equal to 2m by h cross square a whole square. We are going to consider the squaring of all both the side. This will be pi square by 4, this will be this much less than that of the pi square, or we are going to multiply in each h square by 2m. So it will be pi square h cross square by 8m less than that of the a square v0 less than that of the pi square h cross square by 2m. Then what we are going to found? We can found two bound states. See, if we are going to consider the radius is this much, okay, any radius, you can see any radius which is less than that of the pi. Here we taken this is the radius which is less than that of the pi. So how many cut mark we can found? This is one cut with the curve, this is another cut. You can consider any radius. See, here you can consider this radius is belongs to less than that of the pi. Also we can get the two cuts mark. Here you can consider this radius, this circle one cut mark we can found, two cut mark we can found. So the radius in between pi by 2 to pi, we can get two bound states. One belongs to first group. This cut mark or intersection is belongs to first group. We can found the even parity wave function. This is belongs to second, because dark line is belongs to odd, second class. So as this is here the intersection on the dark line, so hence the second one, the other belongs to the second group or second class, belongs to odd parity. So whenever the intersection on the even or the first class, we can get the even parity wave function. For the second class, we can get second class or second group, we can say, we can get the so called odd parity wave functions. Okay. Now third eye, as a square v0 increases, a square v0 increases. First here a square v0 is less than that of the pi square h cross square by 2m. Okay, here a square is somewhat increases for this case. For this case, a square v0 square, a square v0 square is somewhat increases. That means here pi square h cross square by 2m less than that of the pi square h cross square by 2m. But in this case, in between, greater than that of the pi square h cross square by 2m, but less than that of the pi square h cross square by 8m, less than that of the pi square h cross square by 2m. That means here in the second case, when we consider the radius is pi by 2 to pi, the a square v0 is greater than that of this value, pi square h cross square by 2m, means it is increased. When a square v0 increased, the intersection also increased. So if we have to increase further this a square v0 value, the intersections also will be increased. Okay, so that things here it is written that as a square v0 increases, more energy levels, that is intersections, appear successively for even class or even group and odd class or odd group. You can see that here for radius, this radius circle, only one cut, one solution belongs to even. For this one, two cuts, one for even parity solution, one is odd parity solution. For this circle, we can found three intersections. Here for the one even parity solution, this is cuts with second class. So odd parity solution, this is cuts for cuts or intersects with even or first class solution. For this intersection, we can get the even parity solution. Okay, so in this way we can get the intersections whenever increase of intersections, whenever the radius is going to be increased or the so called a square v0 is going to be increased. Now we have to come to the, this is your this is completion of page number 10. Now come to the page number 11. What we have been concluded, that I have been written in this page, you just watch it. I am going to be discuss. So from the graphically what we discussed here, what are the things what we found? See, number of bound states are finite and depends on a square v0 for a given mass. That means for a given mass of the particle which is trapped inside this potential well, suppose the mass is m, this is region 1, this is 2 and 3, we can get the alternatively even and odd parity solutions for the region 2. Now, as we have to increase the value of a square v0, the bound states, the energy states alternatively even odd parity is going to be increased. See, as we have to increase a square v0, even odd increases, if you have to consider another one, this larger circle, see this one, here will be quart mark, even, odd, alternatively the energy levels is going to be obtained. Now the ground state is always an even state, even parity. The next bound states are alternatively odd and even states. See, and the ground state means this one. This is the first energy state or the first bound state of the particle, or the ground state, which is intersects on the first class solution, or you can say the even solution or even parity solution we can found. So the ground state, this intersection is indicates the ground state, first state. Ground state always be even parity. So but the next bound states, these are the next bound states considering the larger radius, alternatively even, odd, like that. If r in between 0 to pi, there is one even parity state, what we discussed. If r is belongs to pi to 2 pi, there is two even parity states. So in general, the even number of parity bound states, the even number of bound states, how much we can found? Any minus 1 pi less than r, any pi. So NE will be the even parity bound states if we have to consider any minus 1 pi r, any pi. That means here pi to 2 pi we just found here, pi to 2 pi. 0 to pi, the number of bound states, even parity bound states is 1, 0 to pi. One even parity state. See, 0 to pi, 1, whatever may be the radius, you can take for the first radius 1, second radius 1, third radius also 1. Means 0 to pi, whatever may be the radius, you can get the one even parity, right? Now if we are going to consider pi to 2 pi, pi to 2 pi, the radius, you can get two even parity states. See, this is one even parity, this is another even parity. Pi to 2 pi means whatever may be the radius, this will be the radius, suppose in between 2 pi, you just imagine this one, maximum this will be the radius, you can get one even parity, another even parity. Okay, similarly by considering this two equation, you can write if NE minus 1, see, pi less than r, NE pi, then NE is the number of even parity. So suppose 2 even parity, so 3 even parity, if we are going to consider 3 minus 1 pi r 3 pi. So if we are going to imagine 3 even parity I am going to be found, that means we have to take the range is in between 2 pi, 3 minus 1 is 2 pi r 3 pi. So in between 2 pi to 3 pi we can get NE is equal to 3 even parity solutions. Likewise, there are no odd parity found, no odd parity bound states. I am going to erase those things. Odd parity bound states we found in between 0 to pi by 2. See, 0 to pi by 2, there is no odd parity because this is belongs to your ground state. Okay, this is belongs to ground state. So in between, actually in between 0 to pi by 2 there is no even possible, because this is belongs to the curve of even one. So there is no odd parity solution is going to be found in between 0 to pi by 2. Odd parity not to be possible. That it is written that there is no odd parity bound states solutions for 0 to pi by 2, radius 0 to pi by 2. There is one odd parity bound state in between pi by 2 to 3 pi by 2. See, pi by 2 to 3 pi by 2, in between this, whatever may be the radius, only one bound state. See, this is one bound state, this is another bound state. Whatever may be radius you can consider. This is the circle in between pi by 2 to 3 pi by 2. This is the circle in between pi by 2 to 3 pi by 2. So in between that, whatever be the circle you are going to be draw, you can get only one odd parity, because these two intersection belongs to even. Dotted line, dotted line. This is only one odd parity solution you can get. So in general, anyone can be right. Suppose N0 is the odd parity bound state we want to found. So this is the expression for the range of the radius. That means suppose we are going to be consider N0 is equal to 3. Suppose we are going to consider N0 equal to 3. N0 equal to 3. 3 number of odd parity state we are going to be found. That means what will the range? See, 3 minus 1 by 2. 3 minus 1 by 2 less than that of the R. 3 plus 1 by 2 pi. Sorry, this is pi. Pi, this is pi. Okay. So 3 minus 1 by 2 is how much? This is your 5 by 2 pi less than that of 7 by 2 pi. So in between 5 pi by 2 and 7 pi by 2, if we are going to consider the radius range of the radius, then we can found your 3 number of odd parity solutions. So in our figure we can consider up to, this is your 3 pi by 2, this is your 4 pi by 2, 5 pi by 2. I am going to be draw you for you, just imagine. Suppose this is your, see, this is 3 pi by 2, 4 pi by 2, and this is your, actually I don't have space, but I will be draw with adjust. This will be 4 pi by 2, this is 5 pi by 2. The another will be 6 pi by 2, then another will be 7 pi by 2. Okay, we are going to draw the circle. You just imagine. In between 7 pi by 2, we are going to consider in between 7 pi by 2. This will be the circle. So this is your odd. So this will be the dotted line. This will be the even, and then this will be the odd, and then this will be the even. So how many chords or intersects with the odd? See, this is 1, this is another 2, and this is another 3. So 3 intersections on the odd curve or on the odd solution we found. That means 3 odd parity solutions we can found if we have to consider the radius range in between 5 pi by 2 to 7 pi by 2. Okay. Okay. Likewise, in this way we have been written the general expression, the radius range, to finding the number of odd parity bound state solutions. Okay, this is the expression of the range of the radius. Now we are going to be represent the Eigen functions. Say we found that the ground state is always even parity, then the first excited state will be odd parity, the next one will be the even parity, like that. So this is your region 1, region 3, and in case of region 1 it will be decreasing function. This is decreasing, this is decreasing and decreasing. Okay, that means here we can say the probability of finding the particle will be finite. It's not to be 0, it is there, the wave function is present, means the probability of finding the particle in this region. Maybe classically it is forbidden, region 1 and region 3 both are forbidden, classically forbidden, but we can get some probability of finding the particle in region 3 and region 1 also, because wave function, after solving we got the wave function, no, so we got the wave function, means there is some but it is decreasing manner, we found. You can see this is the wave function. Here psi 1 and psi 3 we got the value, this is the definite value we got. That means 100%ly we have some probabilities on the quantum mechanics point of view. Here also for the region 1 and region 3, even if for the odd parity, for this is suppose odd parity, for the odd parity also we can get psi 1 and psi 3. For even parity solution, means suppose we are going to consider ground state and second excited state, also we found the psi 1 and psi 3, means either may be odd and even, we can get the probability of finding the particle in region 3 and region 1. There is some wave functions, but it is decreasing wave functions, psi 1 or psi 3, here also psi 1 and psi 3, decreasing wave functions in region 1 and 2, but region 1 and 3, but region 2 alternatively we can get the ground state. Okay, actually alternatively we can get the even odd like that. See, here we represented the three states. Means you can say that we are considered this one. That means the potential, this A means your width. This is your width. We taken the width is this one. Width means this is minus A to plus A. So this is 2A. So if A is constant, or 2, this width is constant, so A is constant. But if V0 is going to be increased, if V0 height is going to be increased, obviously A square V0 is going to be increased, right? So if this width is steady, and if I am going to be increase the magnitude of V0, that means A0 V square is going to be increased. So as we saw from this discussion, that if R or the so called A square V0 is going to be increased, the number of states is going to be increased. Suppose this is the particular situation. This is one situation in which the value of A square V0 will be different for this situation. Okay, so for this situation, or for this third circle, you can say the A square V0 is different as compared with this one. So for this case, or for this case, suppose A square V0 we are going to be consider a particular value, then for that A square V0 we can get 3 energy state. So again, if we are going to increase V0, that means A square V0 is going to be increased again. That means the range of the radius is going to be increased again. That means suppose A square V0 is going to be increased. That means we have to increase V0. That means potential magnitude of potential again I increased. Means A square. See, if A square V0, if it will be increases, so obviously this radius is going to be increases. Suppose we are going to consider another increased radius, suppose this one. Okay, that means we got the 4 energy states. This is one intersection, this is another. So even odd, 4 states we can get. So here you can perceive one thing, that as this V0 depth is increases, the bound states increases. For V0, for this case V0, whatever the V0, for this case V0 is increases. See, for this one is V0. Suppose this is 1 V0. suppose for this one is 2v0, for this one is 3v0. Here this 3v0 is greater than that of the 2v0 is greater than that of the 1v0. That what is the meaning of this? Meaning means this depth is increases. So as the depth is increases, depth of the well is increases, the number of bound states is increases. The number of bound states. For this case only we can get only one state, one bound state. For this case we can get two bound states. For this case we can get three bound states, right? Likewise. Okay. So here I can give you one example that if you are inside your home and the restriction is going to be increases. Whatever the restriction initially it was there, restriction means potential or bondage is going to be increased. Means your anxiety in your mind is going to be increased. That means your states of thoughts, different things is going to be increased. So as much as you are free, the different thoughts is not going to be induced in your mind. But as much you are bounded in your room or any portion is going to be bounded to be live in a room, then it's many things, many thoughts will be induced in mind. Means number of states, bound states is going to be increased if we have to be increase the width, depth of the well. Okay. So what I am going to say that, so this is the three states here I represent. So likewise we can also consider higher states or higher energy levels by considering the increasing value of V0, depth of the potential. Okay. So here from figure 4, this is figure 4, it can be found that the Eigen functions are similar to those of the infinitely deep potential well. May you remember that whenever we have been discussed infinitely deep potential well, I am going to show you, wait. So this is the things what we discussed at that time. This is the infinite deep potential well. That means there is no probability of finding this side and this side. This is because these two walls are infinitely potential, infinitely restricted. So the wave function for this case we found like this. Means there is no probability of finding this side and this side. So the ground state is this one, is equivalent to this one. See, the ground state is equivalent to this, is equivalent to this, is equivalent, but there is the difference here. The probability we can found in region 1 and region 3, but here there is no probability this side and this side. For second excited state, see, a node is at center, a node is at the center. So the maxima and maxima at the two side. Okay. And for the third excited state, here at the middle it will be maximum. So at the third excited state it is maximum at middle. So this and this, the wave functions or the Eigen functions or the behavior, you can say, the behavior of the particle is similar. If we are going to consider infinite deep potential well and finite deep potential well, both are similar, but here is the some extra things we can found. That means infusion of the particle in the region 1 and region 2, infusion of the particle in the classical forbidden regions, right? So here those similar to those of the infinite deep potential well, but wave functions slightly penetrate into the classical forbidden region where they decay to zero exponential, what we discussed. Okay. So these are the alternative even, odd, even parity wave functions or bound states we found by solving graphically these two equations with the so-called circles what we defined this one. Okay, so here we have to stop our discussion because the video otherwise it will be too long, and it will be somewhat difficult that you are going to be watch full video. So so here we are stopped our discussion, and in the next class we are going to be discuss about the Eigen Values. Okay, whatever the here we found the Eigen Functions, and that are we found the alternative even and odd parity wave functions or Eigen Functions, and this is the graphical representation, and what will be the value or energy value or Eigen value for this state, and this state, that we are going to be discuss in our next class. Okay, so thank you so much for watching this video. I suggest to all of you that go for this video carefully, don't be hurry, carefully you have to watch this video step by step. I discussed, you can pause the video and you can write the note, draw this figure perfectly, this figure and this figure, and go through each and every step. And if you faced any problem in the mathematical derivation or any physical background, physics, if you faced any problem at the time of discussion what I discussed, you can contact with me. Thank you so much for watching this video, and I suggest once again that write down your note and ready for the next class. We are going to be discuss about Eigen Values of the functions whatever we got. So thank you so much. Thank you.